guys, what we discussed in a networking. So we discussed about what is network, what is networking, internetworking. So we discussed about NICs, MAC addresses, IP addresses, devices like a hub, switches, routers, modems, cables like a coaxial cable, twisted pair cables, fiber optical cables we discussed. And we discussed about a OSA model, application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. And IP address, again IP address and MAC address differences. And IPv4, about IPv4 we discussed. IPv6, only 2 points I told. There is few more points out there. Of course, you can read already I given. Next. So there is a network troubleshooting, so which I separately will tell network troubleshooting, but we discuss about ping related issues like that. Next one is trace RT command, IP config command. Okay, IP config all command also we discussed. ARP already I told. Okay, and only a topic what I'm trying to say now, it is about what is this private IP address and what is the public IP address, what is NAT, what is PAT. Okay, that's what we are discussing now. So we'll see that. Okay, start with the what is a private IP address, guys. So you are in your own LAN network, means you have an organization. In your organization, you have your network. We will get a shapes from here. This is your organization. In this organization, you have a devices. Okay, either in your home or maybe in your office, you have a devices. Means computers are there. Okay, and you want to communicate between these devices. Means you have to connect the devices like this. To switch or a hub, you have to connect it. Connection is done, but to communicate, we need an IP address. Assign an IP address to each and every device. So this is your LAN network. So we can able to communicate from one device to another device. But what IP address I have to assign? This is your private network, guys. Your own private network. Your device is not required to communicate from internet. From internet, your device is not required to communicate. Not required to communicate. So you are not connecting to any internet or outside connectivity. Okay. You have to communicate from here to here. So you have to assign a private IP addresses only. So you need to buy any private IP address. You can pick up any private IP address range and you can use it. Depends upon your size of network. You can choose either class A or class B or class C. Of course, you know already class A is a very big size network, means number of hosts in a class A is 16 million. So in a class A, it is 10 series network. So 10.0.0.1, 10.0.0.2, like also you can assign. For example, you have a very big network, then you can use 10 series. Even a small network, 50 computers or 100 computers or 1000 computers or 10,000 computers or 1 lakh computers. You can use class A also. Okay. So no restrictions, because when it's a private means it stays in a private. It's no problem with anyone. So I am getting an IP address. The same IP address I am using in my private can be used by so many people in the world. But they are using in their private only. I am using in my private only. Okay. So this 10 series, if you see a 10 series IP address, it is a private IP address. Or you can use 172 series. Not 172 series, guys, 172.16 or 17, 18 up to 31. These are all private series only. 172.16 network or 172.17 network or a 172.18 network up to 172.31 network. These are all private IP networks only. Okay. But all are different networks. Or I can use 192 series. 192.168. Okay. 0.0. This is the first one. This is class C, means first three are network portion. This is first two are network portion. This is first one is network portion. Means this is won't change in the entire private network. 192.168. This is never changes. But network changes. This is another network. This is another network. Like this. 255. Another network. So almost 256 networks we are getting in a 192 series. 256 networks we are getting in a 192.168 series in a class C in a private IP addresses. Networks. Each network, again 254 devices we can connect it. Here it is 16 to 31, it is around a 15 or 16. It is we have to calculate differently. So the difference is 15. Means it is 16 totally. 16 private networks we are getting. Okay. So 170.16.0.0 to 170.31.255.255. This entire range is private IP address range. 10.0.0.0 to 10.255.255.255 is entire private range. 192.168.0.0 to 192.168.255.255. Private IP addresses can use by any person or in a home or any organization within their private network, within their LAN only. You need to pay for any thing for a private IP address use. No need to take any permissions or a registration, not required to use a private IP address in your private network. Private IP addresses are non-routable, means with your private IP, you cannot communicate in the internet. Okay, you can't communicate with the private IP address. Okay, non-routable kind of stuff. To communicate in a public, means internet, we need a public IP address. You want to communicate. Okay, you want to communicate in the public, so you need a public IP address. To communicate in a private IP addresses are enough. But to communicate in outside, you need a public IP address. Okay. So then here it is. Your devices are assigned with the public and how to get a private public IP. See, here it is, guys. I have a server. For example, this is a web server. In my organization, they developed a web server and running a web server. Someone in the internet, they want to access this web server. How they will access in my web server? So they go through internet, they have to reach me. But if it is a private IP address, so they cannot able to reach. So what I have to do? So I have to ask my ISP assign a public IP address to it. Okay. So it need a public access, public connectivity, and public IP address to get access from internet outside of my network. Okay. But you want to access it from internally. So IP address different. This is a private IP. Okay, and this is public IP. So what thing is we can't access now. So what we do, we'll change things. Okay, so simple first point is anyway to access a device from the public, compulsory required public IP. Even you want to access in the public, you need a public IP address. You need a public IP address. To communicate from here to here or here to here, we don't require public IP. Within the LAN, private IP address. But you want to communicate outside of the network, you need a public IP address. Okay. No, not required that much close. But this is my web server. Again, these are all assigned with a private IP address only. So for example, I assign 10.0.0.10. This is .11. This is .12. This is .14. Okay. Private IP address only assigned. But how it will able to communicate to public or by public? Okay. It is private. It is public. So what type we will do it? We do a NAT translation. Network address translation. Network address translation. What is NAT translation? To communicate outside of your network means from your private network means to public network, you should connect it to the public internet and assign with a public address. Okay, but using NAT, what it will happens? You can stay private. Your IP addresses are private IP addresses only. But when you are communicating outside, you will communicate with a public IP address. Okay, just like in your home, you have a home nickname, but you are telling outside when you go outside in a public, so people will call you with your main name, right? Public name. Private is private, public is public. So how this NAT works, we'll see. In a router, we have to configure like this. Actually, we're not configuring it in our home networks, but in organization, they will do it. Okay. This is my IP address. 10.0.0.10 is assigned to a public IP. For example, it is 120.0.5.10. I take another one. So 10 dot 0 dot 10 dot, sorry, 0 dot 11. Second device. 120 dot 0 dot 5 dot 11. 10 dot 0 dot 0 dot 12. 120 dot 0 dot 5 dot 12. This is not required to be same, guys. It can be anything. Okay. It is a public IP. So I purchase 4 public IP addresses for my 4 private IP addresses. I have 4 devices need to communicate in the public and from public also. So what I have done, each device, their private IP is mapped to a public IP. So you have to buy a public IP address. You have 50 devices need to connect. You have to buy 50 public IP addresses. Of course, either one public network or a specific public IP addresses like a after subnetting. Okay. So these are the 4 private IP, 4 public IP address I have. So public IP addresses must be purchased. So you have to register, and then I need a public IP address. Then you will get a public IP address ranges as per your requirement. Okay, guys. Now how it is communicate? How it is communicate? This is a device is sending a packet with a IP address of 10.0.0.11. It going out, then it go out like this is a .11 pack IP address mapped to this 120 0.5.11. You try to reach the destination. This destination will give a reply with an IP is 120.5. Some 11 kind of something and reach up to here. In this one again it is translate to your this 11 and give it back to this PC. Okay, this is how it is going on. So when it is outside, it go with the public IP. It's mapped public IP. Outside people knows this public IP only, not your private IP. Okay. Next one. This is my web server, right? Someone is trying to access my web server. Okay. So they will put a 14, right? So it is, they will put an IP address like this. 0.5, 15. Okay. So request go up to here. And it is translated into the 14 and give it to this. And this will reply with 14. Again, translate it back and give a reply like this. This is what happens in this network. In the router, we have to configure like this. This is network. It's a one private, one public. You have a 10 private IP addresses, you need a 10 public IP. You have 100 private IP addresses, 100 public IP addresses are required. For example, in my office, there is a 50, 60 members are currently working. And 50, 60, more than 50, 60, at least 100 devices are there. It means 100 public IP addresses I have to buy. Think about like it's an organization. It's okay, no problem. Think about in my home. Already I told there is a TV which is connected in a network. And I have my laptop and there is a mobile phone, there is a tablet, there is a TV, one another computer is there. Okay, and my sister having a one computer, my brother-in-law having one computer, their mobile phones, things like that. All over in one single home, we have around 5 to 10 devices which is need to connect in the network. All required public communication, right? Means 10, all 10 members require 10 public IP address. If I'm going to buy 10 public IP addresses, it is very cost of internet. Second is our IP addresses, that too we are using IPv4 addresses. IP addresses are very limited. Like this, for every device you want to communicate, so compulsory you have to migrate IPv6. But not completely, we are not migrated to IPv6, right? Still we are using IPv4. Public IP addresses are limited and it is cost. It is not suitable for our home type of networks. Where it is suitable, where we are using a server kind of stuff. Thus, you have a server in your organization, it should be accessed by public, then definitely this is work out. Okay, compulsory this type of network. In our home, it is not like that. Let's understand what is NAT, private, public. For example, in my home, I'm in my private network, right? So when I'm in a private network, I use private IP addresses only. But I need a internet. So I need an internet. So I will connect it to outside of network. In internet, guys, no one is not required to connect to your device. You are sending a request outside and you are getting reply for outside. Like you open a google.com, so you will get a reply from google.com. You open a facebook.com, you will receive a things from the facebook.com, right? It is not automatically coming to you. You are getting connected. Means you send a request, you will get a reply. That is important in the internet. So we are all using like that. So that's why our network is highly secure network. It is, we cannot buy more public IP addresses. Next one is we need an access internet and we are using private IP address. NAT is 1-to-1, but I have a 10 devices are there. It means I need a 10. I have a 10 devices means I need a I need a 10 public IP address, which we cannot able to offer by people, and we cannot waste that many IP addresses here. So they use a technique called a PAC technique. Port address translation. Port address translation, also called as a NAT overload. Also called as a NAT overload. Okay. How it is happens. For example, again, guys, take a 10 series, like a 10.0.0. And this is 14, I said now. So this is 13, this is 12, this is 11. Okay, this is private IP addresses are there. And to communicate outside, you need a public IP. That won't be changes here. There's a public IP required. For example, my public IP address is 120.0.5 dot something like a 6. This is my public IP, one public IP, which is actually maintained by ISP. So we are not choosing any particular public IP. ISP will do that job for us. So we not to buy any public IP address also. Okay, we are paying for internet. So ISP is taking care of this thing. So when I send a packet from 10.0.0.11 and it goes with this public IP only. Okay, so for example, you are sending a request to google.com. It goes up to here with this packet and going with out with this public IP address. It reached the destination. Destination is giving reply. Reply comes with your public IP only. Again, it is translate and you receive. But there is a problem. For one device, one public. But I have a 4 devices. I need a 4 public IP addresses. So this is second device. But one public IP only. All are communicating with a single public IP for all devices. Sometimes based on organization, so or based on the service providers, they use 2, 3 public IP addresses. Okay, so guys, here it is. How it is differentiate means I got a request. I'm sending a request with this one, it goes with this one. I'm sending with this request with this IP address, it goes with this one. But how it will be differentiate? So it will use the port number. For example, this port number is 33. So it will assign like this. 34, 34, 35, 35. So instead of directly assigning a public IP address, it maps them into means multiple private IP addresses, single public IP address we are using. That is called a PAT technique. So in NAT 1-to-1, in PAT many to one or all to one. Okay, so PAT port address translation. So we are putting many to one. That's why it is NAT overload. But how it is differentiate? They use a port addressing means a random port allocation number is there. So then it will be bind map with that port numbers. Okay. So with this technique, guys, you cannot be accessed by anyone. You can't access it by anyone. Okay. It means someone is trying to access your device directly. You didn't send a request. Mhm. Someone is trying to access your device from here directly. With your private IP, they can't access. With your public IP, also they cannot access. Even they send with your public IP, it reaches up to here. But they know the public IP address, but the binding point, they don't know, right? What is the binding thing? Here it is port number. And it does not know what is the private device. Up to with public IP, they will reach up to here. But who is the private device? It can be 11, it can be 12, 13, or 14. You don't know, so it will drop the packet. Okay. So in this one, no one will come and hack you. If even they know your private IP or a public IP address, they cannot send a packet to you. They cannot hack, they cannot send something to you. Okay. Until unless you have to send a request. If you open a website, it means you send a request and you'll get a reply from the website. That's why, guys, we are by default in the secure network. We are by default in the secure network. Where is dangerous network? Open network kind of stuff. Like you go to railway station, so one internet is connected to many people. Okay, so you are not separated from others. If any hacker in that one, so they can hack you. Of course, not that is also difficult because of there is encryption of individual devices also there. Okay, that part is also not always, guys. Hotels, some coffee restaurant, coffee days kind of stuff. Okay, so people go, they'll give a free Wi-Fi connectivities. So they'll connect to the laptop having tea, coffee, or burgers kind of stuff. And while they are working. Okay. So the point is there are already connected into the public. If someone is there is trying to connect. So there are in the same network. Another danger one is opening the illegal websites. Tiny links means some small URLs people will share now that sometimes is connected to some different remote servers. Okay. So you're sending requests, you open some illegal website, some hacking website, some pornographic kind of content websites, torrents websites. So they may contain this kind of thing, like when you send a request automatically, so they can able to give a response. Any response, any kind of packet they can able to deliver once you are asking for a connection. Other than that one, you are safe in the network. You don't require any VPN, a separate VPN for securing your network, not required until unless you are doing some illegal activities. Okay. So this is a PAT technique, guys, port address translation. In our home, this is a home kind of network. It is, I've given like this. This is internet, ISP, Wi-Fi router, or private network. From Wi-Fi router to ISP, then it is internet connectivity. This is public network from ISP. ISP to Wi-Fi router, one network. Wi-Fi to our other devices, one network. ISP to outside, different networks. Okay. That is about your private IP addresses. NAT and PAT techniques, guys. NAT and PAT. Network address translation, port address translation. In our home, office, lot of lot of private IP addresses means we need a lot of public IP address. What we are using? Port address translation. Okay, so guys, compulsory go through the all networking part first. Anything we miss out, if anything I am missing out, any doubts, you can discuss tomorrow class. Okay. Okay. Yeah. That's it for today, guys.